Hello and welcome to NOV Live. I'm Michael Gaines, host of the podcast NOV Today, and glad you are with us today as we continue our weekly conversations around technology in the industry and bring in subject matter experts to give you insight and allow you to ask your questions to the experts as well. So we'll be having a great conversation today talking about subsea storage and all of the concepts and ideas around that with our guest, Kristian Michaelson, who's joining us live from Norway. We'll be sure to get him in just a moment. It'll be a great conversation. We also will have our regular segment with NOV's Director of Business Strategy, Asad Mahana, and we'll be talking about the happenings and current events on the markets and what we can be looking forward to as well. So before we get to them, we are going to head over to Shelby Dumaine, who is NOV's digital communications specialist, and she's going to let us know how you can be a part of today's conversation and a little bit more. So, hey, Shelby, good to see you.
Hey, Michael, it's good to see you as well. So if you're new to the show, maybe haven't been here before, I just want to go a little bit over how you can join the conversation. We're live right now on Facebook, LinkedIn, or YouTube. So at any point, if you have a question for any of our guests, you can comment it in the comment section. And I'm there live throughout the show, looking at comments, responding to them. And we're going to try to get to as many of those questions in the show as we can. Speaking of the comment section, it's time for my favorite segment, Rig Geeks.
Rig Geeks, Post of the Week.
All right, so this is the part of the show where I ask you at home or at work a trivia question, something about a little bit around our topic, and see how many rig geeks out there in the comments know the right answer. So today's question is, what is the maximum height of a subsea storage tank? So we have a photo we're going to pull up right there. So what is the maximum height of a subsea storage tank? Now, you can say it in meters or feet, but whoever comes closest to correctly answering the question, and about the first 5 minutes of our show, because we will be answering it in the interview, will be winning an NOV water bottle. If you can see, it's an NOV brand water bottle. These are great. You can fling all the plastic and start using a reusable water bottle. So if you answer that question, what is the maximum height of a subsea storage tank? Meters or feet, it doesn't matter. The first person will win the water bottle.
All right, that sounds good. So an appropriate gift for a technology that has a water theme. I like it. So
exactly.
All right,
your own storage tank.
Yeah. So the maximum height of a subsea storage tank. So the first 5 minutes, whoever answers that'll win the water bottle. Sounds good. All right. Thanks, Shelby. We'll check back in with you in just a little bit.
All right,
so as we mentioned at the top of the program, today we are talking about subsea storage units and not only the technology, but concepts around that. And to help us understand a little bit more about this space and to give us some insight, we have Kristian Michaelson, who is the manager of commercial operations for subsea products here at NOV. So, Kristian, thanks for joining us, and let folks know where you're joining us from.
Hey, thank you for letting me come. I'm sitting in Oslo, Norway, so that's where I'm based. But of course, our clients are global.
And I'm curious for this late day in May, how was the weather today?
Actually, it's nice this day, so that's very unusual. So,
all right. Well, hopefully you get to enjoy it.
Yep.
Good. All right. Well, Kristian, maybe we'll just kind of jump off and as we like to do here at NOV Live, we like to assume that those that are watching may not know as much about the technology. So maybe we'll just kind of start with the basics. So, we're talking about subsea storage units, which can be used for offshore oil and gas collection. So maybe we should start the basics. So why do we look at why is there oil and gas production offshore, and why not do it all just on land?
That's a very difficult question, but I'll try to answer it a little bit easier. The easy oil is gone, so we have to go offshore to actually get enough oil to meet the world demand. So basically, there are two ways of producing oil offshore. That's via dry wells placed on a platform, or subsea wells, which are on what we call Christmas trees or valve trees, which are tied back to a platform, either a floater or a fixed platform. And actually, the first subsea well was completed by Shell in 1961. And today there are thousands of wells subsea, and with the deepest wells in Brazil or the Gulf of Mexico. And many of the world's largest discoveries are now placed far away from land or in deep waters, which means that we have to develop new technology to make these discoveries possible to develop.
Okay, so when you start looking at production offshore, maybe you can kind of help our viewers walk through, how NOV is a part of that, and if you can maybe even kind of walk us through a little bit more and the offshore production process and what that looks like.
Of course. Yeah, since we're trying to answer our clients' problems in multiple areas, we need to get hydrocarbons from the seabed, and for processing, transporting, how to get it back to land, how to make the topside process. And it's a little bit hard to explain, but the subsea market is basically split into several segments, and we're part of many of them. And the first segment is the subsea production system, which is called SPS, which is focused around the subsea trees and the wells and the manifolds. And then there's the second market in subsea, which is what we call SURF, the subsea umbilicals, risers, and flow lines, which is taking care of all the infrastructure on the seabed and also the installation. And now in the new market setup, there's also a third, which means the EPCI market, which is consisting of alliances, which actually combines the SPS and SURF into one delivery. And then the fourth one is export systems, which includes large export lines of gas or oil, so-called trunk lines. And what NOV wants to do is to differentiate and focus on unique and innovative technologies, in addition to our well-known standard products, of course, like the flexible pipes. And we don't want to be another hardware supplier who are competing in an already very crowded segment, but we want to focus on our new disruptive products, which are subsea water treatment for injection. It could be automated pigging operations, and of course, subsea storage solutions, which we're going to focus on today.
Yeah, so maybe we can talk a little bit more, obviously, about our primary topic. So, we've seen a lot of development, and I know, especially in NOV, innovation in the subsea storage, and really a lot of really driving more towards an unmanned operations type of approach. So, can you kind of unpack that for us? What's been the driver in that space?
The driver for unmanned operations, that's the subsea storage is one of the new building blocks that are needed because we need to unlock stranded reserves and marginal fields. And a low oil price environment also will require new thinking and new technology to reduce the break-even cost of the oil fields. So some of the new solutions would be modular technologies that could be redeployed to other fields, and also designing the products for easier installation and retrieval as well. And by doing that, we're also looking into more integrated deliveries with fewer interfaces. And the subsea export system, which we're basically talking about today with the storage, also includes the full infrastructure and also the offloading system towards the tankers.
So, I know we were looking at some imagery that showed kind of a setup, especially from a subsea storage standpoint. So, for those that might not be familiar, what would a conventional method look like for maybe for storage offshore, and maybe secondarily, kind of what are the kind of standard offerings, or what's in the market right now?
Yes, the main driver for developing storage solutions is to replace what we call the floating storage unit, which is called FSO or FSU, which is basically a manned vessel which stores oil, which would require both a crew and a high power supply to be operational. And the subsea storage system, that's a fully unmanned system, which then require minimal amounts of power, and therefore the OpEx cost for running such a system is also quite low. So, yeah, the FSOs are used as a storage facility, basically together with the platforms with no integrated storage. This could be fixed platform like you see on the picture here, or it could be used together with floating facilities like spars, semis, or TLPs, which doesn't have any integrated storage on the platform. So on the next picture here, as you can see, this is a spar platform, then connected to a storage system, and then again offloaded to the tanker that you can see on top there.
Mm-hmm.
And today there are basically 100 FSOs deployed in different oil fields, and a major part is actually together with a fixed platform. So the market is quite big, actually.
So if you're just joining us, we're talking with Kristian Michaelson, and he is the manager of commercial operations for subsea products here at NOV. And we're talking about subsea storage and the not only the technology, but concepts and outlook in that space. And so if you have any questions about subsea storage units, or question for Kristian, who's our subject matter expert guest for today, feel free to put your question in the comment section, whether you're joining us on Facebook, LinkedIn, or YouTube, and we will try to get your question here on the show in just a little bit when we get to our Q&A section. So definitely want to make sure that you are a part of today's program as well, since that's one of the primary reasons we want to bring our subject matter experts right to you. So Kristian, wanted to maybe talk about some specifics around the benefits and some of the advantages that you see from NOV's subsea storage units. What are some of those things that kind of are top of mind for you when you look at the technology that you and your team are offering?
Yeah, I will try to run through that a little bit. So basically, our system is it's based on storing the oil inside the membrane, which then can be used at any water depths. And this membrane is protected inside the outer shell. And that means that our system doesn't have a direct contact between oil and water. And this direct contact between oil and water can actually cause bacteria growth layers, which we call emulsions. And this is avoided when you have the oil inside the membrane. And in addition to that, the system will also have a dual barrier against leaks, since if the membrane is damaged, the oil will then be gathered in the top of the dome, since oil weighs less than water. And from there, the oil can be pumped out and retrieved, and the tank can then be replaced. And conventional storage tanks that are in the market today, they only have one barrier against the leaks, and it's very hard to retrieve the system as well. So on the photo here, you can actually see a picture from one of our tests on the tank itself. This is a small version, but we have tested this in many cases.
Right. So, go ahead.
No. So since the system, doesn't have to account for this emulsion layer, which means that such a layer can be up to several meters tall, we can design the system 30% smaller than conventional systems. And we also don't require special handling when you offload, because these offloadings can take up to 36 hours extra, and you need to have dedicated slop tanks on the tankers to actually take care of these emulsions. So
I just wanted to maybe a quick follow up. So you just said you can design the system, up to 30% smaller. Why is that an important concept to know?
That's just the price picture, basically, because price of steel is quite high. So if you could do it 30% less, you're talking about thousands of tons of steel saved.
Okay. So I mean, we're looking at the picture of the unit. So one of the first things I think of is, okay, so what are you actually able to store in the units?
The original thought was to actually use these to store processed oil or condensates. But since we have spent many years on developing the system, we have now seen that we could also use it for other fluids. And these fluids could be chemical storage, which could be both like buoyant or non-buoyant chemicals. But also we can use these for settling of produced water, which comes from an oil field together with subsea separation. And this picture here that you can see on the screen, that shows a cluster frame consisting of several tanks to store different type of chemicals in different sizes. So the large tank here could be used, for example, for MEG, or lower volume chemicals like scale inhibitors or demulsifiers can be stored in the smaller tanks. So the concept of storing chemical subsea, that can enable longer tiebacks or save a lot of topside space as well on congested platforms and assets.
Okay. So when you, well, actually, before I get to my next question, I think we actually have some questions that folks have already started to generate, which I'm glad to see. So if you're okay with that, Kristian, we'll actually try to get some of those questions answered. So because I don't know if they're like me, perfect. I like to get my question answered as soon as possible. And if it's something that we cover later, we can certainly mention that. So we'll go ahead and bring in Shelby Dumaine and see if we can get some of those initial questions that we have answered. Hey, Shelby.
Hey, Michael. So we've actually gotten several questions about OPEX. We've got one from Elaine asking how much is OPEX per barrel, or about reducing OPEX. Can you talk a little bit about the operating benefits and cost and how it compares to traditional means?
Yes, of course. Since this is an unmanned system, we basically don't have a crew. And on a storage vessel, you can have a minimal crew of maybe like 7 to 15 people. And those people cost quite a lot of money. And you also need to have electricity and power to actually run the accommodation, the cafeteria, and everything on this ship. So basically, yeah, we need maybe 10% of the power since it's unmanned. And while a ship like this could cost like $15,000 a day just for running it. And that's basically a huge cost saving if you accumulate that over a 24 or 25-year lifetime of a field.
Mm-hmm. So we have another one. This is from YouTube, a username Bromex3000. How are the units anchored? He was wondering.
Yeah, since we're going to install them in a so-called cluster frame, which means that we will put 5 tanks together as one large unit. That one will have a foundation, but depending on the seabed, you could have a suction anchors. You could place it on a rock dump carpet. So that's very, very sport project specific on how that will be done.
Mm-hmm. So we got another one before we go back to the conversation with Michael. This is from John on LinkedIn. He's wondering, what is the lifespan of these storage tanks, and how does being underwater affect the corrosion?
Yeah, that's also a good question. The lifespan of the tanks are plus 20 years, and that's actually something we're testing in a life cycle test on the membrane, which we have proved by using very rough materials that can handle that. And the tank itself, that can be made of fiberglass, so that doesn't have any corrosion issues. And for the structure itself, the steel structure, we will use anodes and, of course, paint, which is common in the subsea industry.
Mm-hmm. So maybe you can also talk about another kind of basic question I have, which are, help me understand the sizes of these structures and how we're providing those.
Yes, they could look a little bit small on the picture, but actually, the biggest one tank can be is 10,000 cubic meters, and that's about 60,000 barrels. And if we put them in a cluster unit, which means that we have 5 and 5 units, that would be 50,000 cubic meters or 300,000 barrels per cluster. And if you need more capacity than that, you can add more of these clusters to make any capacity you basically need. And the height of this tank, it's about 30 meters or 90 feet. And the length is like a big football field, actually. So we're talking about bigger than a house here, or an apartment building.
Yeah, you're right. The picture does make it yeah, once you start putting into scale, I can understand the advantages and certainly the size footprint, which is advantageous. So one of the other items that I've seen in reading up on subsea storage units is, and specifically these, you talk about reducing carbon footprint, which I find interesting. So help me understand the connection between reduction in carbon footprint and subsea storage units.
Yes, since the main driver is to replace the floating storage units, and those ships usually run on diesel or gas turbines. And we have actually calculated the CO2 emission savings based on a low manned vessel. And that vessel consumes about 14 tons of diesel per day. And the storage is unmanned, so we only need some power to run the control system and opening and closing of valves. So as the numbers show here, actually we can save 140,000 tons of CO2 in a 10-year period, and about 12,000 cars taken off the road yearly. And that's about 120,000 cars in total. And we did this calculation based on the EU average emission on cars. And in addition to this, the positive of reuse is also very positive for the environment, since we could have this as at one field and then move it to the next field, for example, for marginal short life productions. So this is something we have actually developed in relation with the Equinor here in Norway, and also the OGTC in the UK, which is the Oil and Gas Technology Center. And it's also part of the initiative that the oil companies have to reduce carbon footprint by 2030 to about half. And then by 2050, they want to be carbon neutral on their offshore fields. And this is one of the ways to go.
So I think another question that I've had, and I think others do as well, is talking about limitations or considerations when you're looking at these particular units, especially when you're overlaying that thought around water depth. So what does it look like when we're having these units, and what are their kind of recommended operating parameters there?
Yes, the system is what we call ambient, which means that it's not affected by the pressure, and that's quite important if you move to deeper waters. And this means that the actual bottom of the structure is open to the sea, and that means that it's water filled when you install it. And when the membrane is filled with oil, you will actually push this water out, and then the oil will then fill up the membrane. This means that it's not affected by the outside pressure, and the same principle design can be used in 100-meter or 1,000-meter water depths.
Wow.
So you don't need to design a pressure vessel, basically.
Yeah. Wow. That's really interesting. Yeah. It was interesting. Now that you're saying that, looking at the time-lapse video we saw a moment ago, I'm starting to piece that together. So then thinking through, a lot of the designs and considerations in developing this technology, obviously working, with your team, working with customers to develop and provide this. What does the future look like, and what are some things that you're looking ahead, especially in the subsea storage space?
We see the subsea storage future as quite bright, since in the past we have seen that there's been installed about 10 subsea storage tanks already, and those are common tanks made of concrete or steel with no membrane. So we think that our system is a major improvement on already field-proven components. And also from a decommissioning perspective and reuse. So this is one of our benefits on marginal field developments, and that they will become more economical to develop. And one of the main issues is a high capex when you're going to develop an oil field. And we have actually looked into a typical marginal field and done a business case where we looked at the 30,000 barrel per day production rate, and we reduced the break-even cost with $1 per barrel just by adding the storage tank instead of a storage ship. And this was done because basically the storage tank was half the price of the ship. But if you would count the OPEX cost accumulated as well, then you would probably have the double saving from that. So since we see large benefits, we have done quite a lot of qualification projects since we started this in 2012.
Okay. And so, when you're looking at, you're talking about other capabilities that exist for the offshore production space, because I think, there's, when folks are looking at technology nowadays, they're trying to find ways to maximize the application of technology in as many ways as they can. So how does that apply in offshore production?
Yeah, in offshore production, the system needs to be field proven, and that's difficult for the first project, of course, or it needs to be qualified, which means that we have had the qualification program ongoing for several years, where we have done tests on all the subcomponents and also putting field proven components into a system. And this is the full system that we're actually testing today, and which will be ready by end of next year.
Okay. No, I think that'll be really interesting to see, and I think looking forward to that. Speaking of those that are watching, we want to go ahead and get some additional questions that have been put in the comments. And again, if you're just jumping in, glad to have you. We're talking about subsea storage units, and we have Kristian Michaelson, who's the manager of commercial operations for subsea products here at NOV, and we're talking all things subsea storage. So if you have a question about subsea storage units or the technology that NOV has and what that looks like, feel free to put your question in the comments section on LinkedIn, YouTube, or Facebook, and we'll try to get to your question here. And so with that, we'll go ahead and bring Shelby Demain in and see if we can get the other questions that have been rolled in.
Absolutely. So this one comes from LinkedIn, and I know we can't always talk about specific installs or projects we've done, but can you speak a little bit to maybe where this has been used, or some of those, a little bit insider there?
Yeah, chemical storage is also a new product that will come to the market quite soon. So there has not been any installed yet, but we have done quite a lot of tests, and also membrane compatibility tests with a lot of different chemicals. So we're actually trying to develop this so the operators have a new building block for their fields.
Gotcha. So this next one, also from LinkedIn, how is oil and gas separated before it goes into the storage subsea?
This storage tanks is actually based on processed oil. So it's for export quality of oil. So which means that we will still need a platform to process the oil and to bring them down to the tanks.
So we got this one. You mentioned that there's the fiberglass coating. So does that have anything to do with the another business unit of NOV's, the NOV Fiberglass business unit?
We're having a very thorough cooperation with our friends in NOV Fiberglass, and they have great experience in making large fiberglass tanks. So they have actually helped us on designing these big tanks and making them hold, calculating the thickness, and it's not an easy job.
I'm sure it isn't.
Yeah, absolutely. So we got a couple questions about how this kind of compares to the floating top storage. Can you speak a little bit to that?
Of course, the cost is very, very project dependent. But in the cases that we have looked into for one cluster, which is about 50,000 cubic meters or 300,000 barrels, then it's about half the cost of a floater.
Okay. So I know that we kind of skimmed the surface somewhat, to use a analogy. So for those that are interested in maybe having a deeper conversation or asking some more detailed questions, I think that you, Kristian, you and your team are going to be working on putting together a webinar for those that are interested in learning more. Is that right?
Yes, that's correct. Together with our sister company, Gusto MSC, we're planning a webinar which are going to talk about subsea storage used together with what we call a MOPU, which is a mobile offshore production unit. And this is type of platform which is very easy to install and also to redeploy. So we're going to have a webinar on showing how we could add subsea technologies to make a hybrid system, and also including hybrid systems for water injection, and also how we then bring all the NOV technologies together and reduce critical interfaces, and also integrate all the topside processes, and also the APL system for offloading.
Okay, great. Yeah, no, I think that'll be a really good conversation. So I think if folks want to express interest in joining that, or want more information, you can send an email to subsea@nov.com, and you can send a note, and the team will be able to reach out to you for more information. Or better yet, we have our subject matter expert here himself, so you can send a note to Kristian, and we'll put his email address there on the screen. Kristian Michaelson at NOV.com, and I'm sure he and his team also will be glad to circle around with you. So I've been talking with Kristian Michaelson, who is the manager of commercial operations for subsea products here at NOV, and we'll be talking about subsea storage. Also, before we go, Kristian, I also want to remind viewers that if they want to check out more information, I think we have a website as well that they can check out. Is that right? Yes,
nov.com/subsea. It's on the screen now.
Perfect. Oh, yeah, there it is. Matt, the magic of digital communications. All right, there it is. All right, well, great. Well, Kristian, been a pleasure speaking with you. Thanks for joining us.
Thank you as well.
All right, so now we are going to move to our next segment, which is going to be the Ask Assad show. So when we have questions about the market and the forces therein here at NOV, we always like to tap on the door of our friendly director of business strategy, Assad Mahana. So Assad, good to see you today.
Great to see you, Michael. Thanks for having me.
So let's jump in and maybe talk about, what are the latest things that we're seeing in the market from observing the moving and shaking that's going on, which has been quite a bit. What have we been seeing recently?
Yeah, it has been pretty active. Oil prices have surged. Surge is probably a big word, but they've increased significantly, about 75% already this month for WTI. Now we're seeing that at close to $32, $34 per barrel. Up from negative territory a little over a month ago. The big question, Michael, that we had earlier was how quick will operators see this as an opportunity to turn taps back on? And while some thought that the answer is obvious, I don't think it's as clear. What we're seeing is that there's a bit of struggle to get those taps turned back on and production regained. We've been used to shale being so agile and being the force behind the volatility of the market. I think that's no longer the case, just because of one extremely fundamental indication we're getting from shale is an extremely fast production decline. We said, and the market did too, but a couple of months ago, that with COVID-19, the price crash, that we'd see about 2 million barrels of the 8 million barrels a day that the U.S. produces from shale, that'll be wiped out by the end of the year. So in about 10 months' time, about a couple, maybe 2.5 million barrels a day. The truth is, and what we've seen is over 1 million in just 2 months of reduced production, which is huge compared to what's been anticipated.
Mm-hmm. So then how did that happen? How did we get to that point?
Yeah, so if we just think about shale just in general, you're looking at the shale well in the Permian Basin that could give 800 to 1,000 barrels per day on its initial production for the first 30 days, say, or 30 or 60 days, and that's where the investors are looking to gain their return on investment. But that requires, to maintain that requires a lot of wells to be drilled on and on and on, because the decline rate from 800 to 1,000 barrels per day is going to drop, quickly, about 50 to 70% decline per year. So you quickly going to see those wells produce 150 and 10 barrels a day within the first 2 or 3 years. What I want to pull up is a graph from Bloomberg that shows nicely what the year-over-year contribution in overall production in the U.S. On a per well basis. And you can see there, Michael, that for a well that's been drilled in 2016, its overall contribution for that year is pretty significant, right? You're looking at that 1,000 barrels per day from that well, but it quickly, it doesn't take too long before that percentage shrinks from the overall production. We say the shale industry is like on a treadmill. We mean that's what we mean. You have to keep drilling. You have to increase well count to maintain that original level of production. And this fast depletion rate, that's a phenomenon ultimately attributable to the shale geology itself, just the nature of the rock. A good example that you can match to that is a champagne bottle that explodes when the cork's off. Shale well will give that eruption when you first frack it, but then the froth will quickly be tuned down and short-lived. And that's just compared to old-fashioned wells, the conventional wells that give you nice, steady, long-term production rates, it's just not the case. So to offset that huge decline curve, shale producers have had to, go and drill north of 20,000 wells a year in shale lately, which is a huge, huge number. So I'll give a couple examples on operators and what they've done in this downturn. Some operators have taken some pretty drastic actions. We mentioned Parsley on a previous call. Centennial is another one that's just completely halted drilling and fracking. EOG and Diamondback, on the other hand, are still drilling with better pace. We talked about ConocoPhillips the other day. Pace of development that's optimized. So you'll see a lot of different producers acting differently. But I think what's really key here is that it's when you're up there and producing those levels, you can maintain them by keep on drilling. But once you've seen that decline, it's not as easy, and that decline curve is going to eventually catch up.
So I think when you're looking at, especially from the decline curve, as you mentioned, I think that there's been a general response that folks have been surprised. And so, I maybe that's my question to you is why is this such a big surprise to folks?
You're right. It's surprising that people are surprised now that we've been drilling in shale for the last 10 years, more even. But the truth is, when you look at investor days or announcements, or when an operator comes out and discloses what their performance like in their earnings call, extremely rarely will an operator disclose their decline curves. So it's all really been academic, some analysis, some analytics around the production, backtracking to what those decline curves are, which is what made them somewhat of an art or a mystery. I want to bring up a quote from an analytics firm I think that hit home well, and I think just it portrays how significant this is. These guys observed that 55% of the U.S. shale production is from wells that were drilled in the last 14 months. This is just mind-blowing. If we look at, it took 10 years to get to the 8 million barrels per day that we peaked at in 2019 before COVID-19 and the oil crash. 10 years. If you think that really those 8 million can be wiped out or wouldn't exist if it weren't for the last just 14 months, or half of them at least, then that's just, that changes the equation quite rapidly. IHS mentioned that about 20% of the decline that we're seeing, remember I mentioned the 1 million that we've seen in the US in shale production, 20% of that only comes from the shut-ins. And there was a big campaign to have operators do that. Just less than 20%. The remaining decline comes from just not drilling well after well after well, and really condensing that field development like a manufacturing plant. I'll conclude with one thing, and you know me for just looking for the bright side, and I really think there is one here, genuinely. This will certainly be painful for many operators. Many companies will struggle to maintain cash flows. But what we've seen is that shale has, in the last 10 years, been the driver, the driving seat when it came to the volatility of the market and destabilization of supply and demand. Some constraints, some capital constraint behavior that's related to field development and optimization of how we address shale will give us two things. One is a reduced cost coming from shale, but also a controlled discipline when it comes to production, making our whole industry a little less volatile and more dependent, in my opinion.
Looking forward to hopefully some additional good news as we march ahead through this summer. I've been talking with Asad Mahana, Director of Business Strategy here at NOV. So thanks for joining us, Asad.
Thanks, Michael.
All right, so we are now going to wrap up this show with Shelby Domain and see if we can get the answer to our Rig Geeks post of the week. So let's, you want to remind folks what that question was and give them the answer?
Absolutely. So the question was, what is the maximum height of a subsea storage tank? We got a lot of really great guesses. I think this is maybe the most answers we've gotten for any Rig Geek segments. That was really exciting. And the correct answer, drum roll, is 30 meters, or roughly about 98 feet. We did have somebody that correctly answered the question. It is Bromex 3000 on YouTube. So Bromex will be contacting you to get your NOV water bottle, your own little storage tank.
Cool. Good. All right. Well, that's great. All right. Well, and I know that we are going to be wrapping up today's show, but we look forward to having you join us again next Wednesday as we have another episode of NOV Live, where we will bring in subject matter experts and continue to take your questions and get insight on additional technology and innovation happening in the world of energy. So from all of us here at NOV, thanks for joining us. Thanks for watching and listening, and we will talk to you later.